So we designed OCR 2017 to allow us to emulate a mega disaster. And how could we better respond with a variety of technologies available to us? The purpose of this is to redefine the art of the possible. How do we leverage the assets and the capabilities that we have today? How do we incorporate the talents of the people that actually get the job done and give them an environment to explore new ideas? Collaboratively work towards creating new capabilities or solutions.
Nokia and Verizon have been the technology partners for a long time now, so building out traditional cellular infrastructure and various different types of solutions. And we continue to kind of innovate together and collaborate together on various innovations throughout the network. And particularly, obviously in the area of 5G, where we talk about advanced communications. So we're doing a lot of trial and testing work right now on how these new access technologies and how the underlying network architecture can improve the resiliency of that communications and improve the overall coordination for all these response teams as well.
Nokia's main contribution is going to be on the communication side for every first responder. And the key is to be able to set up a comms link back to their operations center quickly, so as to be able to coordinate things better. And that's where Nokia comes in, is whether it's giving folks in a disaster area handheld devices that can quickly connect to a base station so that people have internet connectivity, or just be able to talk to each other, or have a large uplink back from the disaster area to the operations center, for example, or back into the internet. That's where Nokia can help tremendously.
Public safety customers require a variety of solutions, ranging from robust broadband infrastructure to rapidly deployable systems for disaster recovery or temporary coverages. Nokia has a very diverse, robust, future-proof, end-to-end public safety networking solution, and we're really happy to partner with Nokia to show these capabilities in action at the OCR event.
Obviously for us as a technology vendor, it's really important for us to see how 5G and how all these different types of applications and things are actually going to get used. And it's really interesting to see this particular environment for first responders in emergency situations and tactical response teams, and all the challenges that they have in their daily work, which is obviously very critical, important work, and how all this technology that we're developing is vitally important to kind of the work they do and the support environments they are. So it really does bring several new aspects to the way we think about technology and how it's utilized way beyond the traditional consumer and the traditional businesses that we think about that use wireless technology today.
Here today we're with Verizon, illustrating how LTE in the event of a subway attack can go deep into a tunnel and provide coverage where coverage just doesn't exist.
In Bell Labs we have built the most compact LTE network in the world. It literally fits in a backpack, and we have developed it to help our first responders. It provides a private LTE network so they can operate their smartphones and benefit from basically, for instance, push-to-talk communications, video streaming, voice calls, text, etc.
So imagine for a minute I'm not a Nokia telecom engineer. I'm a first responder. My main goal or my main mission is to help victims that are in need, not messing with communication. So as soon as this unit sees power in about 3.5 minutes, it will self-configure and come online and start to support 400 active users.
We have implemented few novel features, so it can be used in, for instance, challenging environments when it comes to GPS, so we don't need any sort of synchronization.
We can submit or transmit high definition video, high bandwidth, low latency through our solution. So that allows a command center to see on the scene what the first responders are seeing. Nokia has a group communication suite. If you wanted to do push-to-talk video, VoLTE, all of those things that are inherent in a wireless network are the exact same things that are inherent in this little backpack.
So this particular demo is a low latency use case, and virtual reality is one of those use cases that human beings are very sensitive to latency when it comes to virtual reality, where if the delay in the network is very high, you will actually suffer things like motion sickness. But what we're doing here is an interactive use case where we're showing a teacher and a student in a VR environment, both connected over opposite sides of the 5G network, and both are able to collaborate, to prototype, to design, and work together in real time.
We're bringing up a lightweight LTE system, so we've taken a Nokia LTE network in a box, and we've miniaturized it so it weighs less than 6 pounds, and that allows us to put it on a tower that's 50 feet high that you can check into aircraft luggage on a normal airplane, or put it on a tethered balloon like you see behind me up to 500 feet high, or like we'll demonstrate tomorrow, up at high altitude up to 50,000 feet high, just depending on how big a coverage area you want.
We covered a 100-mile radius of footprint from the air. So what's nice about covering an LTE network from the stratosphere is you fly above the weather. And when you can fly above the weather while natural disasters are happening below, we're able to provide an LTE network in a safe area. So when the first responder is given all clear, they can run in and start to save those folks that are in need.
Emergency responders, especially as we get into the younger crowd coming into the field now, are all used to apps in their phones and smartphones and apps that'll do everything for you. And we're used to using it in our life, but first responders have their own apps to understand where people are, in what situation, and share information seamlessly. And if they suddenly go to a disaster, there's no coverage, they're sort of left without all those tools that they're used to in their toolbox. And so our systems just allow them to bring along the coverage like they need and they're used to in maybe an urban area when there isn't a disaster that's affected the network. So latency on these systems, even though they provide up to 120-mile diameter of coverage, basically a whole small state, have extremely low latency. So unlike a geostationary satellite where just over a half a second latency, this has less than 1,000 seconds of latency. So effectively it's the same latency you'd see on your standard cell tower, but it covers a big area.
For first responders, uncertainty is the nature of the game there. So you never know which situation you're going to be called upon. And wherever you get deployed, you don't know what the communications capability is going to be. Will there be an LTE base station nearby? There may not be. You may have to deploy satellite antennas. And when you deploy satellite antennas, what type of spectrum will you have available? This system can allow you to pick up all those slivers of spectrum and any other residual bandwidth and aggregate it together and give you a bigger pipe. So this is an example graphic that explains the VSA very simply. Imagine you had 3 slivers of spectrum here, 2 megahertz, 3 megahertz, 1. What this is showing is the ability to pick up those slivers and create a 6 megahertz slice. So this is aggregating these slivers, creating a bigger, fatter pipe for you. And here's an example of the graphical user interface that is used for controlling this box, which implements this aggregation capability. So this box is called the VSM400, and it's got supports up to 4 channels, and so you can aggregate up to 4 slivers of spectrum. And the box at the other end puts it all back together for you. You can also set this up so that if one of these spectral slices were to experience an outage, if you have interference or if you have equipment failure, this can rapidly reconfigure and make sure you have continuity in your service.
Network connectivity is often the first priority of any rescue operation, since it's often compromised in disaster situations. In partnership with Nokia, we can provide a secure, resilient, and reliable network for industry-specific applications and devices from our ecosystem public safety partners.
In this demonstration here, what we have is these 3 robots, and we have the camera here which is capturing the position of the ball on the plate. And it's transmitting that information back to a mobile edge cloud server over our simulated 5G network to these individual 3 robots here right now. And when it transmits this information, it tells the robots the position of the ball on the plate and how to balance them in the middle of the plate. So right now we've set this up in 4G mode. So what I'm going to do is move the position of the ball on the plate. And we can see here right now it takes some time for the robots to understand what the position of the ball on the plate is, because there's that delay in the network. So this actually causes problem for them to communicate together. So the next mode of operation we're going to have a look at is 5G mode. So with 5G mode, what we've done is reduce the delay in the network by over 10 times. And we're going to do exactly the same test again, but we're going to see that the robots are actually able to balance the ball in the middle of the plate much quicker. So you can see that overall reduction, that delay in the network is very important when we talk about real-time communications for the controller machine, specifically in that critical first responder moment for things like drones or remotely operated vehicles.
So there's 3 main advantages that 5G has over current technology, and it's in terms of scale for each of them. The first one is it gives you this unlimited pipe, so you can send high quality video, for example 4K video or even better, and get that granularity that you need with high quality video and not worry about filling up the pipe. The second thing that 5G brings is this low latency, which is an ultra low delay in the network. So you can have responses going on in real time in two-way communication in terms of having a situation where an alarm is developed and then you can respond to it. The third thing 5G brings is the scale, because you're looking at Internet of Things, you're looking at smart devices, and now they're talking about having millions of these devices deployed all over the place. And so how do you get all of that connectivity in one single network? And that's what 5G can bring you.
In the future of 5G, we're also going to have something called network slicing. So network slicing actually allows us to create different virtual networks on the same physical infrastructure. And within those virtual network slices, we can actually maintain a certain level of service. They're actually recorded for specific different types of traffic. And we have special mechanisms in the network as well to make sure that packets are actually transmitted with a higher guarantee level to actually increase that overall reliability in the network.
No one entity can do this by themselves. It takes the community. And this community effort started around a collaboration with Verizon, Aegis, Nokia, and the Guardian Center. And that core group decided, look, this is something, it's a pretty big idea. And we're not afraid of big ideas, so let's go do something instead of talk about it. And what better way to do that than assemble a group of the brightest, smartest people that we could find that do certain unique, specific things and bring them all together. So everything from cutting-edge video surveillance to motion detection to unmanned systems, operations of all of the above. It just allowed us to put together a group of 200 people that you literally could drop into any crisis scenario and we'll find a way to solve the problem.
It's like a executive briefing on steroids, right? So we have things that are in market, right? So right now I'm sitting in the satellite, one of the satellite trailers, right? This is a very widely distributed solution, very mature. But then we've got other things like LTE connections on drones, which are relatively new, or very, very state-of-the-art robotics. These robots are now enabled with high-definition cameras, with artificial intelligence.
Some people had some telemetry sensors where they were recording things like biosensor data for like chemical reactions, for chemical attacks. And we were thinking about, well, okay, it's small packets of data, so it doesn't matter how much data is transmitted on the network. But actually what was really critical to them was that that data was transmitted at exactly the same time because the timestamp marking from recording to the time where you actually analyze the data is very, very critical. So understanding that information, so there should be no delay in the network. So they were very interested in creating networks like 5G that have very low delay. So they had this timestamp synchronization very accurately, so they could build a very clear picture if there was, you know, a chemical type accident incident there, and they could analyze that data. So it's very, very interesting aspect to have a look at there.
Well, I just love seeing things live. Very hard for people to understand, you know, they don't see it and touch it, you know, what is it you do? You know, it's kind of like there, but I don't really know it. When you come to a day like this and you see everything live and you see the effect that it can have on people's lives and safety and security, you take away a different emotional connection to what technology can do for you, as opposed to just being a utility in the wall.
Both Verizon and Nokia are using technology to make people's lives better and safer. It's at the heart of both companies' vision, and it's how we exercise our social responsibility.
The final thing to think about in first responders are inches and seconds. And I think that those two things matter the most when trying to get communications out to the critical edge where communications are needed. So if there's somebody that needs you, they're under a pile of rubble, as we're going to show today, or a drowning scenario, inches and seconds save lives.
So it's really important as we work together as a technology partner to work with Verizon as the provider and also their customers as well to really understand how all of this technology comes together in a solution that can be deployed and used in all these very critical situations.